So they got some of it. They did not get all of it. You're going to move to this spot of your notes, and you're going to cross this off right here. And we are going to insert this. I'm trying to adjust for our time that we have. We got to work with the time that we have. New formulas. We've got some new formulas. The nice thing is we don't make any of them up. They all come from this beautiful thing called the Pythagorean theorem, which is a squared plus b squared is equal to c squared. From the Pythagorean theorem, we came up with the formula for the unit circle. What is the equation for the unit circle? It's very similar to that.
X squared plus y squared equals what?
Sweet! Everybody see how those are related? Okay, and then the other day you learned that when we're talking about trigonometry and unit circle, that x is the same as something. X is the same as cosine. And y is the same as sine. So now we have cosine of theta, that quantity squared, plus sine of theta, that quantity squared, is equal to 1. And in trigonometry, we don't write it that way. We use a little bit of a shorthand. Sine of theta squared, instead of writing it like that, we actually write sine squared of theta. And then we write cosine squared of theta is equal to 1. And that, my friends, is the most important formula in all of trigonometry. You must remember that. That's not one that you are ever allowed to forget. For example, what is the capital of Minnesota?
St. Paul.
What's the capital of the United States? Who was the first president of the United States? Those are things you don't forget, right? You lock them in. They're important. They're just things that are like, we should know that. That's one, you never want to forget that. Ask any kid in calculus, they'll tell you sine squared plus cosine squared is 1. You use it all of the time. Here's another one. We learned that tangent of theta is equal to y over x. Who can see what tangent is then equal to as well? Y over x. What's y? Sine, and x is?
Cosine.
So tangent is the same thing as sine of theta divided by cosine of theta. Once again, you ask people who took trig last year, especially calculus students, and they will never forget that tangent is sine over cosine. Absolute must. They can share this with their dad, and he'll get all giddy and excited, right?
Yep.
See if he remembers them, okay? I want to know which ones he remembers and which one he doesn't.
Okay.
I bet he remembers that one.
What should I ask him?
Ask him, Dad, what is sine squared plus cosine squared?
Okay. I'll ask him.
And then ask him what's sine divided by cosine. I'm guessing he remembers those, but I'm guessing he doesn't remember the next two. And if he does, I'll be very impressed with him, and I'll even maybe take him out for dinner. Probably not, but maybe. Okay, so let's go to our third and fourth formula. In order to get our next formula, we're going to take sine squared of theta plus cosine squared of theta is equal to 1. And what we're going to do is we're going to manipulate this formula by dividing through by cosine squared. I'm trying to keep good pace today. If I go too fast, ask me politely to slow down and I will. I won't make fun of you, okay? All right, what's sine divided by cosine? So the t rhymes with tangent. Tangent. So sine squared divided by cosine squared is tangent squared. I'll give you an easy one. What's cosine squared of theta divided by cosine squared of theta? 1. I have 1 over cosine squared. What is the reciprocal of cosine? Reciprocal of cosine? Not cosecant, but secant. So you get secant squared of theta. This is formula number 3. I give all of these formulas I give you today, you get them all for the test. But to be clear, you're much better if you learn to remember them. Trust me, I see what's ahead of you. And people who remember these, They do better, especially when it comes to chapter 7. There's no question. And then the last formula that I want to show you, we're going to again start with sine squared of theta plus cosine squared of theta is equal to 1. And this time, instead of dividing through by cosine squared, what do you think I'm going to do? I'm going to divide through by sine squared and see what I get. So again, we don't make anything up in math. We just use things that we're given and manipulate and look for new formulas. And we have sine squared divided by sine squared is 1. We have cosine squared divided by sine squared. Anybody know what that's going to be? Cotangent squared, good. And then 1 divided by sine squared, cosecant squared. And that, my friends, is formula number 4. So a lot of times people don't remember formulas 3 or 4. Again, to heighten the concern, absolute must. You are not allowed to forget that. Absolute must. You cannot forget that. You need to find a way to lock it in your brain. Look at it every day. Look at it every lunch. I don't care what you got to do. Don't ever forget that. This is one that I do use a fair amount, okay? But people don't always remember that one. I'll admit, folks, this one really doesn't get used hardly at all. When it comes to chapter 7, we'll use this a little bit, but these other ones get used a lot, especially the first 2, okay? All good there? All right, so flip it over to the next page. So our goal today, we have one more piece we have to set up before we're ready to do these 2 problems here. But once we set up this next piece for you to see, that's going to be, again, very useful to you. We want to do these 2 problems, and then we want to do 2 problems in your assignment today together as well, okay? Want to get you started and ready to work on that. So at the bottom of this page, you're going to draw a quadrant. And there's a big difference between copying down the things that I write and really trying to understand why what we're writing works out, okay? So the last one, sometimes people just end up memorizing the formula, so be it. This one, you really want to understand why this is what it is. And we're going to start with the values of the quadrants. For the points, we have positive for x and positive for y. And we get to quadrant 2, we have negative for x and positive for y. In quadrant 3, both are negative. And in quadrant 4, we have a positive and a negative. Everybody good with my construct so far? So we want to talk about where sine, cosine, and tangent are positive and negative, what kind of values that they have, all right? So if you consider sine, sine is the y value. And in the first quadrant, the y value is positive. So sine is positive in the first quadrant. Cosine is the x value. So cosine is positive in the first quadrant. In tangent, we divide the 2. So positive divided by positive is positive. So tangent is positive in the first quadrant. What about quadrant 2? Will any of them stay positive in quadrant 2? Why will sine stay positive? Because it's the y value. Sine is positive in quadrant 2. Notice that since cosine is the x value, cosine is negative. Will tangent be positive or negative? Because you divide the 2, you get tangent is negative. Talk with your peer next to you and see if you can predict quadrant 3. Take about 20 seconds. Talk. Go. Okay, sine and cosine are both negative, but it does work out that tangent happens to be positive in that situation because you have a negative divided by negative is a positive. Then finally, when you get over to the third quadrant, you have sine is negative again, Cosine switches to positive because the x value is positive, and then we have tangent is negative. So remembering where certain values are positive and negative, very important. Again, I constructed this. How do I think of it? I think of it very simple. Think sine is the y value, so sine is positive up, it's negative down. Cosine is the x, so it's positive to the right, it's negative to the left. Tangent, where they're the same sign, they're positive, where they're opposite signs, they're negative. Or people notice my motion, tangent is the same as slope, so it's positive in the first and the third, it's negative in the second and the fourth. That's how I think of it. A lot of students don't think of it like that. A lot of students use an acronym. I didn't learn this till I started teaching here. I think I saw it in a book, and other students had referenced it. But there's an acronym. It goes, all students take calculus. It's not true. Not all students do choose to take calculus. Some end their career before that. But if you notice, this is saying that all of them are positive here, whereas S, sine is the positive one here. T, tangent's the one positive here. And C, cosine's the positive one there. You see that? So however you want to remember it, it's up to you. I still, all the time, I always just think sine is y, it's positive up, negative down. I mean, that's how I think of it. By the way, all students take calculus. Very untrue. Juniors, as you start to think about next year, for those who may not take calculus, it's important for you to think about if you're ready to end your math career. We have probably, I would say, about 8 seniors this year. They're not taking calculus. That probably would have been cut out for it, but chose not to. The chances that none of those 8 need to take calculus in college, chances are a couple of them are going to have to. Hopefully they find out sooner than later. It's always rough if you end your math career like your junior year, and then you find out like your junior or senior year of college, you got to go back and take calculus. How do you think that goes?
Bad.
So just ran a student the other day. They're trying it for the 3rd time now. They failed with the first 2, so they had some tears. So anyway, but hey, but sometimes people want an easier senior year. Go ahead, take the easy senior year if you want. It's fine. All right, so let's go on up here. Here we go. Let's get to the nitty gritty. Find the values of the 6 trigonometric functions given the following information. I have sine of t. I have cosine of t. I have tangent of t. I have cosecant of t. I have secant of t. And I have cotangent of t. It says find all 6 values given sine is negative 4/5 and that the angle sits in the 3rd quadrant. Can anybody think of something I can write down right away that I know?
Sine of t.
Sine of t is negative 4/5. Can anybody think of something else that I automatically know right away?
The reciprocal.
The reciprocal, cosecant's the reciprocal, right? Negative 5/4. Anybody confused by that? That's really important. Every once in a while, we'll get to this problem on the test. People will write IDK. And I'm not joking. I just want everybody to know ahead of time. At that point, I do call parents. And I say, I don't believe you're prepared to go off for college. And people think that that's really, really like a harsh thing to say. I just challenge everybody. Look at those. Everybody agree you can write those down?
Yep.
Absolutely. Okay. It's always an awkward conversation. Please don't make me have it. It's pretty tough. So sometimes there's tears and anger. So all right. So we got those 2. Now after that, it does get a little bit harder, but fortunately we have this great formula. The formula is sine squared of theta plus cosine squared of theta is equal to 1. And notice what that formula does for me. It says if I'm given a sine value, I can find a cosine value. Now, notice what this says. This says sine squared, which is the same thing as sine of theta, that quantity squared. So you're not plugging in negative 4/5 for theta. Negative 4/5 goes in for all of the sine. So it's negative 4/5 squared. What do you get if you square negative 4/5? 16/25. So I get 16/25 plus cosine squared is equal to Anybody know what I'm going to write instead of 1 over 1? 25 over 25.
Where did the theta by the sine squared go?
Sine of theta is negative 4/5. So this doesn't go in for sine, it goes in for sine of theta.
Got it.
Goes in for the whole piece.
Yeah.
All right, I'm going to subtract, and I get cosine squared of theta is equal to 9 over 25. What do I do now? I will square root both sides, and I get the cosine of theta is equal to plus or minus 3/5. Talk with the person next to you right now. Do you think it's a positive 3/5 or a negative 3/5, and why? See what you can figure out. Go, have that conversation.
Yeah.
I think it's because it's in like the third quadrant.
Yeah.
Five, four, three, two, one. It is a negative 3/5 because I'm working in the third quadrant. The third quadrant indicates that the cosine value will be negative. And so secant is negative 5 over 3. Look at that. We have 4 out of the 6 already done. Wouldn't it be great if there was an equation that involved both sine, cosine, and tangent?
There is.
There is. All you have to do is take sine divided by cosine to get tangent, don't you? So we just take negative 4 over 5 and divide it by negative 3 over 5. And I don't multiply, or I don't divide in fractions. Dividing fractions is just silly. Instead, I multiply by the reciprocal. And when I do, the 5's go away, and I get 4/3. So therefore, cotangent is 3/4. Now we're going to do one more problem in your notes, and we're going to work a little bit on your homework together, make sure you feel really confident moving forward. But this is usually the #1 type of problem that people get wrong on the test. So if you can do what we're doing today, you have the opportunity to get an A+ on this next test. And I would say the next test is easier than this test. And then it slowly gets harder after that. But we want to start out third quarter on a really good note, right?
Mm-hmm.
Yeah, so let's rock it. Let's look at the next one.
Thank you.
How did Fortnite go yesterday?
Slept from 3 till 8, and then from 10 till 7.
Good for you, dude. Okay, we're going to have that little test to see whether or not I could possibly have to call home to mom and dad. Go ahead and see if you can write down the 2 things that we know right away.
Do you have any Kleenexes in here?
I don't. I'm sorry. You guys all got the sniffles. 5, 4, 3, 2, 1. It says cosecant is negative 2. And therefore, I know sine is negative 1/2. Somebody wanted to do something with this. We're not going to use that right away. Okay? We're going to use that in a little bit. Everybody okay with the sine negative 1/2, cosecant negative 2? Okay. So let's try again. We have sine squared of theta plus cosine squared of theta is equal to 1. What do you get if you square negative 1/2?
1/4.
1/4. Please always make sure when you square something, you come out as a positive. It never comes out as a negative. Plus my cosine squared. And instead of 1, I'm going to write 4 over 4. At this point, we could subtract and get cosine squared of theta is equal to 3 over 4. We square root both sides, cosine of theta. I can't take the square root of 3, so I just write root of 3. But I can take the square root of 4, I get dos, which is Spanish for 2. And because I square rooted a variable, I have the positive or the negative. And this is the part where it gets a little bit confusing because we're not given the quadrant that the angle is in, are we? But we are given some information that can help us figure out the quadrant.
It's positive.
Why?
Because it's greater than 0. So the cosine is going to be positive.
Let's figure out how Bryant has figured that out, okay? He is right. He's actually thinking that this is located in the 4th quadrant. Let's see why he thinks that. Notice, is sine positive or negative? So that means that you're either in the 3rd quadrant or you're in the 4th quadrant. You have to be either in the 3rd or 4th. Everybody agreed? So then we'll look at our other condition. This says cotangent is less than 0. What does it mean to be less than 0? What kind of numbers are less than 0? Negative numbers. So that means tangent and cotangent are negative. Well, tangent is negative in the 2nd quadrant and in the 4th quadrant. So I have sine and tangent are both satisfy their conditions here. So everybody see the overlap of these two conditions of the 4th? 4th quadrant, cosine is positive. So Bryant is correct. We get positive root of 3 over 2. I flip that to get 2 over the root of 3. So we get 2 roots of 3 over 3. And then to get tangent, we take negative 1/2 divided by the root of 3 over 2. I multiply by my reciprocal. Those cancel, and I get negative 1 over the root of 3. Pause before you flip it at all. Just understand that if you know tangent is negative 1 over the root of 3, then what do you know right now?
The reciprocal is the cotangent.
Yeah, cotangent is just negative root of 3. So I'm just going to flip that right now. And then I can satisfy this. This is negative root of 3 over 3. Okay? Okay. So raise your hand in the past like 2 weeks if you had been a little bit under the weather, cold, anything like that. Okay. So if I can just give a small piece of advice, a lot of you guys are doing everything you can to take care of yourselves. Just number one thing I try to do. So I used to get sick all the time. Things that have helped reduce the amount of times I get sick. Number one, I always make sure I wash my hands before I put anything into my mouth. Okay. So before I ever eat, I'm always washing my hands. Second of all, I try to increase my sleep at night. So I used to be a person who get 5.5, 6 hours sleep each night. Now I try to at least get 7 to 8, sometimes maybe 9. And finally, this is the change for me in the past year. I told you guys before, I used to drink about 4 or 5 Mountain Dews a day, and I never do that anymore, just can't. And now I drink water. And one thing I've noticed is staying hydrated. It's a big deal. So I drink about 2 of these, so it ends up being about 64 ounces of water a day. And the hydration matters. In fact, have you seen my water bottle?
I was looking at that.
See some of the names on it?
Yeah.
Pythagorean. It's my mathematician water bottle. I'm pretty proud of it. Open up your assignment. Okay, open up your assignment. Flipping that assignment to you. I'm going to look at Haley's here. We'll get you guys back on track what we're doing. Good, right there. This is where you guys want to sit. Is this part right here? Okay, this part right here. And for those of you who are following online right now, we're looking at the assignment that says Pythagorean Identities in 5.2. So it's the second to last assignment that sits in your note packet. And so what I want you guys to do right now is we want to try to do problem 1 on our own. Go ahead and see if you can execute problem 1. And then we're going to move to problem 2 and do part of that together. After you get done with the first one, you just go ahead and pause there. Okay, good. So number one is kind of so number one, like if you look in a textbook, that would be the first problem they would give in this example. It's the most basic kind of example. So that's where I kind of get your feet wet to understand the process. So cosine would be 4/5, secant would be 5/4, tangent would be 3/4, and cotangent would be a 4/3. Okay, it's in the first quadrant, so they're all positive, right? So let's now apply it in just a little bit different situation, see what happens if things get mixed up. Obviously, some of the problems can involve some square roots, and that can get a little bit messy. You're going to find a couple of those as you move on. This one doesn't necessarily involve square roots, but it involves a slight change. What do I write down right away? Tangent 15/8, and cotangent 8/15. Always knock those out right away, okay? Got to do that. Now, I then turn to sine squared of theta plus cosine squared of theta is equal to 1. So what do I do then? Kind of a problem, right? Like we don't have sine or cosine. Oh.
Wouldn't you have to use a different equation?
Thank you, Gina. Everybody give Gina a round of applause. Yeah, Gina. Way to go. Gina, what do you want? What do we want to use? You're rolling now. You got it.
Let me
You
look.
tell me, kiddo.
No, you're good.
You got it. We're waiting.
Wait.
Woo!
Yeah, I don't know.
We're cheering for you.
Oh, is it the tangent squared.
Yeah, 1 plus tangent squared of theta is equal to secant squared of theta. Okay? Now you could also use the 1 plus cotangent squared as cosecant squared, but I just really like to focus on those two. I find I really don't have to use that last one. I can always kind of just turn to that one if I need to. So let's see how this works out then. I have 1 plus, I got to square 15 over 18. Oh my goodness.
It's just 8.
15 squared is 225, and 8 squared is 64, is equal to secant squared. So in my work, sometimes what I do instead of rewriting, I just cross off this 1, I write a 64 over 64. So 64 over 64 plus 225 over 64, I get 289 over 64 is equal to secant squared of theta. Square root both sides. What's square root of 289?
17.
So I got plus or minus 17 over 8. Sweet! Right now, work with the person next to you. See if you can figure out which quadrant are you in. 1, 2, 3, or 4. Try to figure out the quadrant. Got to figure out the quadrant. That's worth 2 points on this problem on the test, is figure out the quadrant.
Which one is
Well, it has to be.
opposite? When is that negative?
Less than negative.
It's less than 0.
Because this one's positive, it has to be less than 0. So is it gonna be? And this one's positive down here, so I'm gonna both have to be negative. So it would be third, right?
They're both positive.
Oh, wait, yeah.
Did you guys?
Or
say
only one with
tangent's
tangents
positive?
Tangent's
for one.
positive. 0, so it's
It's positive, right? But and this one also positive.
I think it is.
See, well, the way I'm thinking is like below
All
0.
right, pause, glance up here. I noticed that the tangent value is positive. So first of all, I want to see that you know you're either working the first quadrant or the third quadrant. It's got to be first or third. Any other guess is wrong. Then I look, I see cosecant is less than 0. That means that cosecant and sine are negative. Sine is negative in the third, and sine is negative in the fourth. So the overlapping region is that third quadrant. And the third quadrant, I know sine's negative, cosecant's negative, cosine's negative, and secant's negative. So those are all negative, and those ones are positive. So there we have it. Cosine is negative, secant is negative, so I got negative 17 over 8. I got negative 8 over 17. Now we can use sine squared plus cosine squared is 1, right? Let's do that. Sine squared of theta plus cosine squared of theta is equal to 1. Sine squared of theta plus, if we square that cosine value, if I look back, I think cosine was 8 over 17. So we get 64 over what?
289.
289. We already used that once, is equal to 289 over 289. If we subtract the 64, we get sine squared of theta is equal to 225 over 289. So sine of theta is equal to 15 over 17. Plus or minus. Did we already determine whether it's positive or negative? We did. We already decided we're working in the third quadrant. So we could go back up to our area up here. And we've got that negative 15 over 17. Or negative 17 over 15. That takes care of that problem. So my intention for you guys today was that we would cover the lesson. Then you would come to class tomorrow. We would do one problem per checkpoint. You'd have the rest of the hours to work as a work day. I'm guessing we won't have class tomorrow. If we do have class tomorrow, it's a work day. We're not covering a lesson. So tomorrow the intention was to give you time to work on this. Okay? That's it. Good job, you guys.